This video is going to show you how to come up with a recursive formula for a geometric sequence. We've done this before for arithmetic sequences, but now we're going to do it for geometric. So the first thing to do is to determine if we even have a geometric sequence. And the way to do that is to compare the terms. We want to see if there is a common ratio between each one. So the change between each term in this, if you notice the pattern, 4 to 12, you can do multiply by 3. 12 times 3 is 36. 36 times 3 is 324, and so on. So the common ratio here is 3. And when we are talking about a common ratio and just want to label it something, then we call it just the letter R. So we can say the common ratio R equals 3 for this specific sequence. Okay, so this is important information because this is basically what we're going to use to build the recursive formula. Remember, a recursive formula is one that it allows you to find the value of a term as long as you know the value of the term before it. So it's, again, the building blocks. Looking at how this actually plays out, let's go and put some labels on here. So the first term, the 4, we can call that A of 1 because it's the first term in the sequence. The next term is 12, and that is A of 2. Oops. I need to erase my parentheses here. We got A of 2. And you'll notice this is where we can start building the formula. So 12, that was equal to 3 times 4. Remember that 4 is the first number, so that's A of 1. And then we do it multiplied by R, the common ratio 3. So we had say 12 equals 4 times 3. This is the first time you see that formula start to build here. Let's do one more term in this sequence. So 4, 12, 36. Now 36, that one is equal to 12 times 3. And again here, 12, that was A of 2. So see how we're starting to find that pattern? The previous term is what is allowing us to find the next term in the sequence. So we say A of 2 times 3. So if you're starting to see the pattern, basically what we're looking at is A of, well, let me write it over to the left. So if we have A of n, and this is our list of terms in the sequence. So if I was to say we're finding the nth value, we'd say A of n equals A, and since it's the previous term, we say it's the nth term that we're looking at minus 1, because we need to go backwards one term and multiply that by R, the common ratio. This is the formula for a geometric sequence, the recursive formula, that is. So this would be a good one for you to write down in your notes, but it's also important to understand where it came from. So basically, we take the previous term, multiply it by the common ratio, and we could keep doing that as we add on terms to each, for the sequence to each position. So basically, what you need to do for a recursive formula is just keep this A of n equals A of n minus 1, previous term, times R, the common ratio, and just apply that to the following terms in the sequence when you're trying to find the next one. And that's the process.